All right. So here we all are for project number 10 of our project series. And in this project, we are going to work on large language model, LLM. I know everyone is having an idea about LLMs. You are using LLMs, and being as a language model, it is having a capability to perform various tasks. It's actually a large one which has been trained on tremendous amount of data. Therefore, it is having it is having knowledge of natural language. Also, it do produce the result in natural language only, that is your language. Okay, how this thing made possible? It has been made possible with the help of architecture. Okay, that is what you call in generative AI. Okay, so as the things went, we do have machine learning algorithms, then deep learning algorithms. In deep learning, we performed neural network, and they are capable to learn the patterns of the data in better way than ML. Okay, so in deep learning, we don't want to stick towards only tasks which are just like prediction or classification. And it has been thought that can we generate data also? Okay, and because of this reason, Gen AI came into picture. Okay, what is the architecture? Everything is dependent upon architecture. How you can generate a data? Because you give data, there is a model, and it will produce data. Okay, so input, output. What is a model? What we call as a model in machine learning, model is a equation, mathematical equation, simple mathematical equation. In deep learning, you call it's an architecture, it's a neural network. So here is a statistical model, statistical equation. Here it is neural network. In Gen AI, again it's a neural network. In generative AI also, it is a neural network only. But what kind of neural network? Is it a simple? No. Neural network, as we know, it's made up of layers. We do have many layers, many types of layers. And yes, in the previous two computer vision projects, that's what we have seen. We were able to transform data in many ways. Okay, you are having image as a data. You use CNN as a layer to extract the feature from it. What you are doing, that's what it's called, CNN, convolution neural network. Obviously, it's a neural network. So if you deal with the image, you are having this thing. If you want to deal with the text, you are having RNN, the recurrent neural network. Because text is a sequential data. So you do perform text analysis. Okay, so recurrent neural network you are having. Okay, then in recurrent neural network, you are having LSTM, long short term memory, bi-LSTM, bidirectional long short term memory. Okay, and then you are having GRU, gated recurrent unit. Okay, all these things, including RNN, they can interpret sequential data. Okay, however, they have an issue. The issue is, okay, they are complex in nature, and they can't perform parallel processing. So time is also a concern here. I can't focus upon specific information that okay, it's going to be important, and if any new important gets added, so maybe your model skip the importance of that information. So we are having concerns related to these models. And in order to improve these models, improve the issues related to these models, there comes transformer. Okay, transformer. And transformer is a breakthrough. That's what you are seeing in the GPT, that is generative pre-trained transformer 3.5. That's a free version you are using. You are also using, um, I think, O also, 4O. Okay, and I guess Mini also. Mini. Okay. So what happens in an LLM is, okay, one more thing I want to talk. Transformer. Okay. Encoder, decoder. These are the two components in transformer. Two neural network architecture. You give input, you take the output. Okay, encoder, decoder. You are having. And a very famous thing, attention mechanism. That's what you are having. And this attention mechanism is now used in most of the projects, in problems where it's been taken to identify, to attend, to focus which part of data is important for us. So, attention mechanism. Okay, I have taught this thing in detail in my Gen AI class. Fine. So, in Gen AI, we are having GANs also, generative adversarial networks. We are having auto encoders also, encoders, auto encoders. GANs, okay, for images, they are used to generate the images. Autoencoders can also be used to generate images, but they prove to be like breakthrough for not only images, for text also, text generation, many things. And that's the reason autoencoder become famous rather than Jan. And what happens in autoencoder is, We are having an encoder. This is an encoder. Okay, I am representing here as layers. This is your data. Okay, this is your data. You perform compression. Okay, you perform compression. That means reduce the dimension of the data. Okay, and keep it in a lower dimension. And then you start decompress your data. That means you try to recreate your data. That is called as decompression. Okay, so this much part is encoder and this much part is decoder. So if your input is X, you're going to produce X dash. Okay, the actually the deal is X dash should be nearly equal to X. And X dash minus X is an error. So this encoder decoder is like a breakthrough, this architecture. And so many problem statements has been solved based upon it, and transformer also been based upon this encoder decoder architecture only, where they are improving the drawbacks of sequential models. Okay, so initially transformer architecture came with for translation purpose. Later on they have been used for generative purpose also, and we are using them. All right, fine. So in my this project I'm going to talk about LLM only, and I will be teaching Llama. Okay, Llama 3, that is an LLM of Meta. Okay, so this model we will be talking what it comprises of. Fine. So let me share my entire screen now, and we'll discuss more on the Llama 3. Okay. So, okay, here it is. This is the official website of Llama 3, introducing Meta Llama 3, the most capable openly available LLM to date. It's on April 18, 2024. That's a notification. Now we are having Llama 3.1, also not so much difference. Okay, it's an upgraded version. Okay, but Llama 3, okay, we are looking forward to work on it. Okay, and openly available. Okay, so it's an open source large language model. We can use it. Okay, for our purpose, and that's what the theme of my project is. I need to perform fine tuning of a large language model. Okay, so it's next generation out of, okay, state of the art model, open source. It is available on AWS, Databricks, Google Cloud. Okay, is responsible AI. It follows responsible AI. That means the result which it will prepare, na, that is not like biased. So it's responsible AI based. There are various versions of Llama. We are having lightweight also, we are having heavyweight also. 8 billion parameters trained Llama, 70 billion parameters trained Llama. That's what we are having. So everywhere now, whether it's computer vision, whether it is LLM, we do have lightweight and heavyweight models. Okay, fine. So there are many things available which I will be covering here in my notes. Okay, got it. So again, Llama, large language model meta AI. That's what the full form of Llama. Large language model meta AI. Generative AI model. It's a group of foundational model developed by Meta AI, a company owned by Meta, which was previously Facebook. Okay. Generative AI, that's what we mean is to generate the content. Something which is generated by AI. Okay, not the humans. So Llama 2 was the first open source language model that was previously released by Meta, and then they released Llama 3 and then Llama 3.1. This is how they have released the models. Okay, it is open source. Open source means you can take the permission from Meta. Okay, you have to fill up a form, and once they approve, you can download the model and you can use the model. Okay, so Meta already started integration of it with Instagram, Facebook, Messenger, WhatsApp. And in 3, they released two types of models for Llama, that is 8B and 70B. 8 billion parameter trained, cutoff is March 23. Okay, and this is 70 billion, cutoff is December 23. Okay, so till here, all the knowledge is available with Llama. So from Llama 2 to Llama 3, what's the difference? What's happening? See, Llama 2 was introduced in 2023, and it is also an open source LLM. It is powerful, efficient model that can run on consumer hardware, our machine. Okay, and this model is having some issues related to like refusing to answer certain prompts, limited helpfulness, and room for improvement is there. That means this model was hallucinating. Okay, so therefore, to eliminate the limitations of Llama 2, Llama 3 came. And Llama 3, it is having 8B, which is a small language model, size with a size of 10 times smaller than Llama 270B. Okay, Llama 2 model with 70 billion parameters trained, it is 10 times smaller than Llama 2. Llama 3, 8B. Okay, and it can produce similar results. Both models are state of the art models. The context size, the token size is 4096 to 8192. Okay, so every LLM do have a context size. See what happens. You give input to the LLM. Okay, this is an input you give to the LLM in form of prompt. Okay, in form of prompt. So whatever be the input you give, na, that is divided into tokens. Okay, that's been divided into tokens. Fine. And this text, input text, is divided into tokens. So it's saying that how much tokens it can take as an input. So the range is from 4096. Okay, you can see that's what they have mentioned here, 4096 to 8192. Okay, to 8192, this much number of tokens. So whatever you are writing, that will be divided, that will be split into tokens. So if the number of tokens is between this range, it can take it as input. If it is beyond then 8192, then till 8192 it will take. After that, discard. Then the rest will not be taken. Also, one more thing, if you give beyond the limit, then it may happen that it will throw you an error and it will say that exceeded. Okay, so that is also one of the thing which you can see. Fine. So here Llama 3 do have this much range that can be further increased, and this is something which is achieved in LLMs. or transformer models or architecture. We were having issue in sequential models related to it. Okay, if I do talk about LSTM, by LSTM, they have an issue that you can't make a sequence of this much length. Okay, that's an issue. Fine. So here you can see giving a architecture and this much token size has improved the ability. So Llama 370B goes further, showing best performance. If we compare to Google LLM, Gemini Pro 1.5, Claude Sonnet, it's much more better than that. Here you can see. This is the performance of Meta Llama 3 in comparison to Gemini and Claude. Okay, and we do test our LLMs on the basis of some like ability to answer maths questions, ability to evaluate, like human evaluation, how we give a feedback to the working of the model, including GK questions also, reasoning questions also. Okay, so that's what they means. These are the parameters. How to evaluate an LLM. What is the rate? What is the response? How better response they are giving. Okay, so 5 shot means okay, giving 5 examples. 0 shot means no example. Okay, no example. 8 shot, 8 example. 4 shot, 4 example. So it's prompting. Short means number of examples you give with the prompt. That is called a short. Okay, so here Meta. This diagram I took from official website only of Meta. Okay, so exashot refers to how many examples the model has been given to learn before answering. MMLU means massive multitask language understanding. Okay, massive multitask language understanding. That means that means AI's ability to understand wide range of subjects and perform tasks based on understanding different subjects. What is the ability of AI to learn about different subjects? GPQA, that means okay, multiple choice questions, domain, physics, bio, chemistry, like this. Human evaluation, okay, evaluating code synthesis. GSM 8K, that means problem solving skills. Math 12,000, challenging problems, competitive maths, how it can solve. Okay, this is how we define the ability of the model. Okay, in this basis they are tested. Okay, the result look fascinating, and you can see the score of Meta. Okay, if I do talk about the architecture, which is very much important, architecture. So Llama 3 model were trained on 15 trillion tokens, 7 times more than Llama 2, which features significantly expanded vocabulary, more efficient text both for input and the output, multilingual, it can understand many languages. Training LLM require large amount of data. To build Llama 3, Meta assembled extensive data set up to 15 trillion tokens, publicly available online platforms. Okay, whatever be the data available on online platform, it picked everything. Okay, it downloaded everything, just like OpenAI did. Okay, they also did the same thing. Okay, and then they have put this data into the model for the training purpose. That is kind of a unsupervised machine learning. Okay, so the data set exceeding 5% of high quality non English data spanning more than 30 languages. Okay, so different languages data it considered. So, Llama 3 potential for chat and dialogue applications. Meta introduced new approach like instruction fine tuning. This method is supervised fine tuning. Okay, supervised fine tuning, rejection sampling, proximity, okay, proximal policy optimization, and direct preference DPU optimization. That's what they have introduced in the architecture. So what it is? Supervised fine tuning. So supervised fine tuning, I just recently taught in my lecture. You have a data which is having target. Okay, that means you are having text and you are having a target. So this is a labeled data. You fine tune your model with this particular data. Okay, that means it can be like question answering, it can be like summary, it can be like code. Okay, so let's talk more about it. Supervised fine tuning. In supervised fine tuning, this is what we do. Okay, um, here you can see by the diagram. You take huge amount of data collected from various sources and you train your model. That is called as base LLM. Then you perform fine tuning. Okay, then you perform fine tuning. Fine tuning means supervised fine tuning, just I told you. With okay, with specific knowledge base, okay, you take a data, okay, you take a labeled data, and then you fine tune your model. Okay, so it will start doing the task according to that, okay, the data which you have used for the fine tuning. Okay, so that has been growing rapidly now. Okay, and initially we do train our LLM with unlabeled data. Remember, initially LLM pre-training is been done on unsupervised. Okay, unsupervised. And then you take a small data and you perform fine tuning of the LLM to make it compatible to answer accordingly. So these people, these Gen AI engineers, they are smart. Okay, they are smart. They have this small labeled data set. They smartly prepared this data set, and this is how your model learned to give the answer. Okay, so the success of fine tuning has led to numerous state of the arts results. Researchers and practitioners align continue to explore variations and optimizations in the fine tuning. Okay, so supervised fine tuning involves adapting pre trained LLM for downstream task. Okay, that means like sentiment analysis, text classification, whatever. So we can take a data based upon it and we can perform the fine tuning of our large language model. Okay, so take today also we are means in this project also we are going to do the same thing. We are available with the data set, label the data set, and we have to fine tune our Llama 3 model based on data set, that particular data set. So during supervised fine tuning, pre-trained LLM is fine tuned on the labeled dataset using supervised learning techniques. Now, fine tuning is been also done with, okay, there are various types of fine tuning. Currently, we are dealing with supervised fine tuning. Okay, see, as I told, your LLM is a huge model. It is trained on billions of parameters. Okay, now if you what is fine tuning? Fine tuning means you need to adjust the parameters, okay, of the model. What are the parameters? Parameters are weight and the bias. These are the parameters. So if your model is having 12 billion, 70 billion, 8 billion parameters, so adjusting this much weight and the bias requires good computational capability, good resources, good memory, everything. If you fine tune the entire model for a downstream task, okay. However, if you want to just perform sentiment analysis, okay, so that for that it doesn't require that you need to full fine tune. Okay, full fine tune, no, that is not required. Only the thing is, that's what I taught, that's what I do say, we can fine tune, or we can adjust few layer weights. That's what we can do. Okay, not the entire fine tuning, we can adjust few layer weights. That's what we can do, not the entire model. Okay, if you fine tune the entire model, it will take time, and that's not we supposed to prefer. Got it? So few layer weights can be used for fine tuning. Okay, so they are mentioning the same thing. It's a process that allows model to learn task specific pattern and the complexity in the labeled data. Okay, then this is how we can say, let's suppose an example for pre-trained LLM. The input is I can't log in to my account. What should I do? Okay, the answer is forgot password option. This is pre-trained LLM. I can't log in into my account. What should I do? Output. Try to reset your password using the forgot password option. Okay, a dry and concise answer to customer support question using pre-trained LLM. Now imagine if you want to build a chatbot for a customer support service, although the answer is correct, it not adequate that it is a customer support answer. We require much more better answer. So we need to train this model to answer accordingly to the customer support. Okay, for that we'll be performing the fine tuning. Okay, that means if someone asks a question that I am unable to log into account, what should I do? Output will be, I am sorry to hear you are having trouble logging in. You can try resetting your password using the forgot password option on a login page. This is how you have to give. Okay, so in case of supervised, your data will be like this will be the input, this will be the output. Prepare a data like this, and then feed this data to the pre-trained LLM to perform fine tuning. Got it? This is called as fine tuning. So now we can achieve the better answers, matching answers. Okay, so we have to provide specific private data which is not available publicly during the training step, so that LLM can adapt its knowledge according to that. Got it? So we have to teach LLM. Okay, teach the LLM to answer unseen prompts. And what is this proximity policy optimization? PPO. Because Llama 3 is also been using this technique in the architecture, PPO. It is a reinforcement learning. See, reinforcement learning is used everywhere now. GPT is also using reinforce. It's using human reinforcement learning. Okay, human feedback actually, HFRL, human feedback reinforcement learning. Okay, it asks for, okay, the answer which is produced by the GPT, whether it is good or not, it will ask for your opinion. So you can give your feedback accordingly, it will improve. So PPO is reinforcement learning algorithm. It is used in machine learning for training agents to interact with the environment. Okay, that's what the reinforcement do now in machine learning. We do have agents, and if there is a mistake done by the model, then a penalty is enforced on it. And if the model perform the good, that means it gives the correct result, then a reward is given to it. That is called as reinforcement. Okay, so in this Llama also we are using reinforcement technique. Okay, like policy gradient method, stability and sample efficiency, clipped surrogate objective, all these things are available in my template. There are many things. Actor critic architecture, BASM, there are many kind of PPO. Okay, the thing is reinforcement learning. That's the approach. Here we can take the human feedback as one of the reinforcement learning, whether the result generated by the LLM is correct or not. If it is not been good, so we can give the feedback. Okay, so according to our feedback, next time it will improve. You can see in the GPT also, it gives you responses, response 1 and response 2. Then it asks which of the response do you like. Okay, you can select on any of the response, so it will now remember that okay, this kind of response is been good one, so that will be considered as a feedback. Okay, got it. Fine. So PPO is widely used in reinforcement. Then direct preference optimization. Okay, this also DPO, direct preference optimizer. It's a direct alternative to reinforcement learning from human feedback. Now they are talking about RLHF, human feedback. Just replace these techniques which are mentioned above with the human feedback. Direct, take the feedback from the human. Okay, so DPU is applied to preference data, which basically consists of data in triplets: prompt, choose an answer, and rejected answer. You can see in the chat GPT also, I told, na, just recently I told. These are the given answers. Okay, what is the prompt? This is the prompt. These are the two answers which the chat GPT created. Which one you selected? I selected this one. Okay, this is rejected. Feedback has been given automatically. Okay, automatic feedback has been given to the model. So next time it will improve. Okay, so DPO, there is no reinforcement learning and the model is directly optimized to the preference data. Okay, not directly exposure, only the selection. What answer you selected, that will be taken as a feedback. Okay, so that is DPO. We are having the prompt. Okay, prompt chosen, prompt rejected. Okay, this is the trained LLM. Whatever we are choosing now, that it will take. And this is the policy which it apply. Chosen score upon rejected score. Okay, this is the loss. Okay, so everywhere there is a maths. Everywhere there is a maths applied. Okay, so here you can see an architecture based upon DPO fine tuning. Which one is selected, which one is rejected by the humans. Okay, so at the beginning of the fine tuning process, exact copy is done for the large language model that is being trained, and its trainable parameters are frozen. Okay, see, remember, we have also used pre-trained models in computer vision. Just recently, we have used, oh no, we have used exception, we have used inception. Okay, so this is pre-trained models. Your LLM is also a pre-trained model. Okay, so as I told, few layers I need to train. Few layers. Rest layers weights. Okay, rest layers weights. I will be freezing. Okay, freeze. I don't want to train them. Okay, that's what I'm not going to do. So just freeze it. Okay, got it. So that's what they are saying. And this is the working. Okay, prompt. Okay, this is chosen, rejected, something given to the LLM. Okay, and this is how the math is going on. Number of tokens, vocab size. Okay, so what's chosen, what's rejected? They are calculating with some ratio. The mathematical formula I have already given, that means it's presented here. Okay, here you can see the mathematical formula. A small way to perform this task is like, okay, 0.34, then 0.21, 0.96, okay, 0.05 and 0.78. It can be like 0.06 also. Okay, or whatever. So these are the values. Okay, so 0.34 into 0.21 into 0.96 into all these six multiplication, this is the answer I'm getting here. So prompt tokens do not contribute to the score. These are certain scores given to the words. Okay, you can see. My name is Mary. Okay, so language model choose and reject response for a given prompt. For each generation step, the probability of generating the response tokens is selected. And these probabilities are multiplied at the end. Okay, so probability of response generation is been taken and then they are multiplied. Okay, so we have given a prompt. Okay, you give a prompt that will be tokenized. Okay, these are the tokens. Then they are given to the LLM, and LLM will generate the answer. This is how it will generate. And whatever it generate, it has been there is a probability for each. Okay, every word it do have a probability. The one which is having the highest probability will be taken under the multiplication. That's what it do. Okay, so this is the formula minus log sigma, beta, and all these things. This is the loss. This is how the loss is calculated. Okay, that will be used to modify the model weights in the gradient descent update. Okay, fine. Well, okay, so these are the terms which I have mentioned here in the architecture. So I thought I should give you a review. Okay, fine. So, huh. So evaluation of Llama 2 to Llama 3. Mark Zuckerberg announced Llama 3 AI model developed by Meta. It highlighted the Llama 3 capabilities, and Llama 2 was introduced in 22. That is having, it's a good one, but then later on some issues which are being improved by Llama 3. Okay, so Llama 3 can be expanded to vocab size of 128256 tokens. This much is the vocabulary of Llama 2. Okay, that means 128256. 128256. Okay, in general 32,000 vocab is enough. That is in Llama 2. But in Llama 3 we are having 128256 tokens. That means it can understand English words, Hindi words, this word, that word, every word it can understand, including special characters and numerical and everything. Whatever we present, this much tokens it can understand. This is the vocab size of Llama 3, and it incorporates group query attention GQA, an efficient representation technique that enhances scalability and helps the model to handle longer context more effectively. GQA, group query attention. Okay, we'll be discussing about group query attention ahead. Okay, let me first introduce this topic. So Llama 3 is, is trained over massive data, 15 trillion tokens nearby, publicly available online, 30 languages it knows. Okay, and it can perform wide range of tasks. It is having all sort of knowledge, historical, coding, STEM, everything it is having. Okay, so okay, here it is now. Okay, fine. What's important here? Hmm. Instruction fine tuning and the performance. There are few things which you can read. I will share the document. That's not an issue. Instruction fine tuning and the performance. See, Llama 3 full potential for chat and the dialogue application, it used instruction fine tuning. Okay, that combines supervised, proximity, and DPO. All three I have explained. Okay, and the quality of the prompts used in SFT and the preference ranking in the PPOs, that means supervised fine tuning, played a crucial role in making this Llama model performance better. Okay, that means it is taking the feedback, that is the reinforcement learning, and we are also performing supervised fine tuning. So, supervised fine tuning with reinforcement learning, it achieved the better results. Okay, and the data set which we are using, that is based upon human provided by human annotators. The quality assurance is given, that means the data is provided by human annotators. Okay, so Llama 3 improved the performance on reasoning and the coding task. Okay, however, model was found to struggle to answer reasoning question directly. It still produced correct reasoning trace. Okay, so that's the criteria over which we do check the model. Reasoning, coding, maths, biology, physics, chemistry, general. Okay, this is how we test the models. So Meta Llama 3 is in top 5. Here you can see. Okay, GPT-4, then GPT-4 Turbo. GPT is always on top. Okay, then after that we are having Llama. Then Bard, Gemini, and so on. Okay, fine. And this is Llama 3 instruct human evaluation. Okay, Meta Llama 370 billion model instruct versus Claude. Okay, this 52% human, that means the people who tested this model, they said it's a good model. Okay, there is a tie between Claude and Llama 12%, 34% says that it's a loss. Then Llama 3 versus Mistral, 59% says this is a good model, 29% rejected Llama 3 versus GPT 3.5. 63 people says that Llama 3 is better than GPT 3.5. Okay, and then with okay, Llama 3 with Llama 2, again 63% people says that it is better than Llama 2. Okay, so this model, as I told, it comprises of few things like supervised fine tuning, okay, plus PPO plus DPO. Okay, that means reinforcement plus supervised fine tuning, and supervise also human annotation data. Okay, human annotated. Fine, and also it applies graphical attention mechanism. Okay, what it is, we'll see ahead. Fine. It also consider safety and responsibility. Meta prioritized on responsible AI. Okay, so this is what they have used. User input, user safeguard, input prompt. It's not like that, okay, whatever be the prompt you are giving, it will produce the result directly. No. There is a system input level mitigations. That means your input is safeguard, then okay, whether it is safeguard input or not. Okay, it's not like that you can query anything to the LLM, whether it is okay, whether it is harmful or what kind of answer, what kind of query you are giving. So there is a filter. First there is a filter, and then this, after checking, after going through the filter, then it is given to the LLM. Okay, then it is given to the LLM. Okay, and then the model response has been taken, again safeguard, again system level output, whether the output given is safe or not. Okay, so Meta conducted extensive red teaming exercises, performed adversarial evaluations, implemented safety mitigations techniques to perform this thing. To support responsible deployment, Meta updated responsible user guide, providing comprehensive resource for the developers. Okay, so there should be system level safety, best practices for the applications. Okay, so that's what the Llama kept in the consideration. Okay, that means they are trying to build, they are much more focusing upon responsible AI. AI should not produce the results which are not good for human. Okay, not for us. Okay, so responsible AI. Detecting content that is unsafe or harmful. Okay, so that's what they did introduce the practice in LLMs. They will classify which content is, which prompt, which response is good, which response is bad. So they have introduced a mechanism in Llama 3. Okay, fine. So, Code Shield, a new introduction with Llama 3, add inference time filtering to insecure code produced by the Llama LLMs, mitigating risk associated with it. So, there is a shield also. So, they have introduced all the filters. Llama 2 is already giving the answers, but now in Llama 3, they have made all these changes to make the model much more safe and better. Okay, got it. Then accessing using Llama 3. Okay, how you can see, you can access Llama. We will be doing the project on this. We're going to do the entire fine tuning on this. Okay, so you can, I told that this is the official website of Llama 3. Okay. And here in this website, they have mentioned their goals. They have discussed about the state of the art. This thing, this diagram, I have already shown you. Okay, what's the performance of Llama 3? This diagram also I have shown you that in comparison of Llama 3 with other models, how it is working. Okay, and in the model architecture, I have told you about few things like instruction fine tuning, which adds supervised and the DPO. Okay, that too I have explained. Fine. And this is the responsible AI. This architecture also, this framework also I explained you. Okay, so all these things I have explained to you. Okay, fine. And you can try Meta AI, like, okay, it's saying try Meta AI. We can try this thing. However, this is you can use Meta AI, Facebook, Instagram, all these things, and you can read more about Meta AI experience here. This is Llama 3 website. Okay, this is Llama 3.2 now, and you can download the models from here. Okay, Llama 3.2, now we are having Llama 3.2 download models. Okay, here are the models. Lightweight Llama 3.2, 1 billion, 3 billion, 3.2, 11 billion, 19, 90 billion, and 3.1, 4.5 billion, 70 billion, 8 billion. See, 405 billion. This much, 405. Okay, all the models are state of the art models. Llama 3.2 is a lightweight. This is multimodal. Llama 3.2, 11 billion, 90 billion. This is text 3.1, 405 billion parameters trained model. This is huge model, 405. And they are saying that you can download. For download na, you can you have to put your name, first name, last name, your all the details. That's what you have to put. You have to click on the model which you want to download. You have to click here and you have to put the next. Okay, so kindly fill the details here, and then you can get the permission to download the model. And you can, once you go to this page. Now from Kaggle also you can visit to this page. Okay, fine. So for example, you will give here your email ID, and on the same email ID, if you have created your Kaggle account, so you will get the permission. Okay, so this form request access to Llama models. You have to fill your details and just select which one you want to use. I think 1 billion and 3 billion is okay. Okay, this is 3.2 version. Okay, currently we are working on Llama 3 and 3.2, and these are the things like lightweight models, cost efficient models they are. Okay, we can download these also, and we can perform the fine tuning also of these models. So you can visit to this website and ask for the access. Rest is fine. Okay, you can okay, rest you can from where you can take the Llama model. I have shown you the website, official website, and you can deploy the Llama also on like AWS and other deployment websites. Okay, to simplify the deployment process, Meta has provided Llama recipes repository, which contain open source code and the examples for fine tuning, deployment, and the model evaluation. Okay, so they have provided an assistance also how you can deploy the Llama model. Okay, so all these details are given. Okay, so the next thing which is been mentioned here, I think we are seeing the next only. This is what is next. Whatever be the template I have shown you, I have explained you, that is Llama 3. Now what I'm showing on the official website is Llama 3.1, 3.2, even more advanced models. That's the next thing. And I'm just also shocked by seeing this 405B, very huge model. Okay, so yes, this is what you can explore from your side. Okay, and here is the end of the explanation for Llama 3. And my next target will be to do the code. Okay, fine tune Llama 3 for sentiment analysis. This is what I will be doing. Okay, fine tune Llama 3 for sentiment analysis. Okay, I will be having financial news data. We can pick up any data for sentiment analysis, and we will be doing the fine tuning of the model. Here is the code. I will explain each and every library, what's mentioned here, what these library do. Okay, and each and every part of the coding I will explain. Fine. And this is your data, fine tuning data. Okay, and then here here are some basic coding. This is what you can take your train in the text data, and then you can generate a prompt. Okay, and then after generating the prompt, you can make a data frame. I already told you that always make a data frame. So extrain data frame, evaluation data frame you can make. Okay, and then this is your y true and y prediction, positive, negative, neutral we will make. Okay, and then finally we are going to take our model, that is Llama 3 model. Okay, 8 billion parameter model will take. We'll be using bits and the bytes configuration to quantize our model, because 8 billion is also not a small thing. If it requires to do the computation, then we have to use BNB. Okay, that means bits and the bytes configuration. We have to quantize, we have to divide, we have to uh, make the things much more simple. That means 4-bit representation. So the bits operations will be done in 4-bit representation. That's what we have to do. Rest is just load the model. Okay, and after loading the model, what you can do is here you can, okay, this is predict, this is evaluate. Okay, and this is how we are going to perform the fine tuning of the model using SFT trainer. There is a trainer, we are going to use PyTorch here for training. Okay, we'll be using PyTorch framework for training our model. Okay, so here the training will be done, and yeah, here it is, trainer dot train. I will call that method. Okay, for one iteration it took a lot of time for me. Okay, so I just done one iteration only. The loss which I get for the training is 0.83, validation loss is 0.77. Okay, and okay, and then, huh, 87% accuracy I'm getting for sentiment analysis. You will say, sir, LLM is given 87% accuracy. Yes. Don't think LLM will give 100% accuracy. No. I have run my model for one EPO only. For one EPO only, 87% accuracy, and you can see that precision, recall, everything. All the score is perfect. Okay, it's looking like balanced scores. So yeah, that's it. Okay, so this coding now I will explain tomorrow for the fine tuning of the LLM. Okay, got it. Fine. Okay, let me stop presenting. Okay, let me stop the recording also.